All right, acceleration of the particle is given. So in order to find velocity and then eventually position, we need to take antiderivatives. So one thing to keep in mind is that the antiderivative of sine is negative cosine, and the antiderivative of cosine is positive sine. So the velocity of the particle at time t is going to be negative 10 cosine t plus 3 sine t plus some constant that's yet to be determined. The position, in turn, is going to be negative 10 sine t. That's because the antiderivative of cosine is positive sine. And negative 3 cosine t plus c times t, because the antiderivative of a constant is constant times t. And of course, I need to add a constant here, because again, any antiderivative produces a constant. So since I have two constants in play, I'm going to call this one C1 and that one C2. Okay, now I can use my given information to figure out what the constants are. It's given that s of 0 is supposed to equal 0. So sine of 0 is 0, cosine of 0 is 1, and of course 0 makes this term 0. So s of 0 equaling 0 gives me that C2 should equal 3. And then the next bit of information I have is that the position at 2 pi is equal to 12. Sine of 2 pi is 0. Cosine of 2 pi is 1. So I have C1 times 2 pi plus C2, I know to be 3. So this is supposed to equal 12. The 3's cancel, and that tells me that C1 is equal to 12 divided by 2 pi, or in other words, 6 over pi. And now I'm ready to report the answer, which is the position function together with the constants figured out. I get negative 10 sine t minus 3 cosine t plus 6 over pi times t plus 3.